Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 6, Section 5, titled Parallel and Perpendicular Lines. By the end of this video, you will have reviewed methods for using parallel and perpendicular lines. Included will be determining if lines are parallel, writing equations of parallel lines, writing equations of perpendicular lines, and a study of the slope of parallel and perpendicular lines. You will finally look at a real-world problem. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to my channel if you find this video to be helpful. Thank you very much. Okay, before we dig in, let's look at a couple definitions here to kind of put in our mind before we start going through this information. Parallel lines. Parallel lines are lines in the same plane that never intersect. Okay. And then perpendicular lines. Perpendicular lines are lines that intersect to form right angles. Right, so we all know parallel lines. I'm going to draw them right here. Let's see. Parallel lines are like this, right? In theory, the distance from here to here is exactly the same as the distance from here to here. And if that's the case in this one plane, here's a plane that these two lines are living on, they'll never touch. Okay? Perpendicular lines in that same kind of a plane, okay? If you have a line like this, a perpendicular line comes through here. It can actually go through and cut it, and it forms right angles. Okay, so that would be this line here, A, would be perpendicular to B. Okay, and I think you understand that. You've known that for a long time now. Anyways, good. Okay, objective 1, parallel lines. In the graph at the right, the red and blue lines are parallel. Parallel lines are lines in the same plane that never intersect. The equation of the red line is y equals 1/2 x plus 3 halves. The equation of the blue line is y equals 1/2 x minus 1. You can see that if you look at the graph, when we look at the plus 3 halves right here, the plus 3 halves part right there, and we see that it's x is 0 and y is 1.5 right there, 1.5. That's plus 3 halves, right? And then we have y equals -1. You see in the blue line, it's down here, the -1. So the lines are parallel, and the only thing that's changed is where they intersect the y-axis. So this is the red line is intersecting up at 3 halves, and the blue line is intersecting at -1. But the lines are parallel, and they can go anywhere infinitely up and down on that y-axis. So what does the property here say? Slopes of parallel lines. Non-vertical lines are parallel if they have the same slope, which in our case here they do. This is a half and a half. Both of these equations have the same slope and different y-intercepts. And of course, -1 and plus 3 halves, different y-intercepts. Any two vertical lines are parallel. The vertical lines are because if you got to look at it, you see they're vertical, right? So what it's saying is that the x, no matter what, it's the same x value all the way. So it's x equals something and the y is changing. And so the slope is always, for the vertical line, is always constant. Okay. Be the same thing for a parallel line. Okay. The equation y is 2/3 x plus 1 and y equals 2/3 x minus 3 have the same slope. The 2/3 is the slope, and they have different y-axes. So this is the definition. So we have to just kind of memorize that. The graphs of the two equations are parallel. You can use the slope-intercept form of the line, of the linear line, so to speak, to determine whether lines are parallel or not. Because once you put it in slope-intercept, this is slope-intercept right here. Slope-intercept form, it's y equals to mx, there's your m, and here's your x. One is x, 1 is your b, and your m is 2/3 in this case. So slope intercept. Okay, so let's move on. Okay, example 1, determining if lines are parallel. Are the graphs of y equals negative 1/3 x plus 5 and 2x plus 6y equals 12 parallel. And then they want you to explain if they are or not, okay? Explain how you determined it. So it's first thing, what are we going to do? We have to get, it said in the previous slides that we have to get it into y-intercept form or slope-intercept. And this y right here, y equals negative 1/3 x plus 5 is in slope-intercept. Here's the slope, negative 1/3, and the intercept is 5. In this form, this equation here, 2x plus 5y, 2x plus 6y is equals 12 is in standard form. And we've talked about standard form before also. Well, what we need to do though is we need to get the standard form equation into slope-intercept. And how do you do that? Well, let's start with the equation. 2x plus 6y equals 12. It's in slope-intercept form. And then when we get it done, we're going to compare it to the y equals negative 1/3 x plus 5. So, and what we're going to want the same slopes and a different intercept other than 5. So we'll find out what it is. So in order to get this in slope-intercept form, we've written the equation. Now we're going to move the 2x. In this line, we're going to move the 2x by subtracting 2x from both sides. From the left-hand side, move it to the right-hand side. So now we have 6y equals negative 2x plus 12. Okay, so we've done that. Now well, at least we have the variables on the correct sides. So now in order to get the y variable by itself, it has to be divided by 6. Well, you have to divide both sides by 6. So here we have divide the left side by 6. We get 6y over 6. And then we get negative 2x plus 12 divided by 6. The entire right-hand side gets divided by 6. Then when we simplify this, we find out that the 6's cancel here. These 6's cancel, and we get y. And then we get negative 2x divided by 6 is negative 1/3 x. And that satisfies the first part of our requirement. And our intercept is plus 2, and the other one is plus 5. So they have different y-intercepts. Therefore, the lines are parallel. The equations have the same slope and differing y-intercepts. Okay, example 1, check your understanding. So if you've worked with me before, you know that on these slides, the check your understanding slides, I'd like you to pause the video, try and work this out yourself, and then when you start the video back up, we'll work it together. I'll wait for a few seconds here for you to do the pause. Okay, so I'll wait for you. Okay, so here we go. So it says, are the graphs of negative 6x plus 8y equal to negative 24 and y equals 3/4 x minus 7, are the graphs of those lines, are the lines parallel? And then explain. So you don't have to graph them, you're just going to do the mathematics here, right? So what did the previous slide say? It says you need both equations in slope-intercept form, because then we can check the slope and the intercept. Okay, so let's start by taking the standard form equation. Here's the standard form equation that we're going to compare against y equals 3/4 x minus 7. So we're going to write minus 6x plus 8y, and that equals negative 24. Okay, so now we have to get this standard form equation into slope-intercept form. Well, it's pretty straightforward. We're going to add 6x to both sides because we have to get the 6x, the x variable, on the right-hand side. They have the slope-intercept form, which is y on the left and x on the right, okay? So we're going to move it. So now we're going to have 8y is equal to minus 24 plus 6x. And the order of these really doesn't make any difference at this point. So now the next step is to get the y variable as the coefficient equal to 1. It has to be y equals something, not 8y equals something. So in order to do that, we're going to fix it by dividing both sides by 8. And when we do that, we're going to get y, because the 8's will cancel. That 8 cancels, and this 8 cancels. So y equals, we have negative 24 divided by 8, which is 8 goes into 24 3 times, so negative 3. And 6 plus 6x divided by 8 is going to be Well, we can divide a 2 out of these, and we're going to get what? We're going to get 3/4. 3/4 x. And if I rewrite it, it'll be y equals 3/4 x minus 3. And let's check. Is 3/4 slope here correct? Yes, 3/4 is the slope up on the top. And how about -3? Is that different than -7? And yes, they're different. So therefore, the lines are parallel because they have the same slope and differing y-intercepts. Okay, example 2, writing equations of parallel lines. So let's read what it has to say here. It says, you can use the fact that the slopes of parallel lines are the same to write the equation of parallel line to a given line. To write the equation, use the slope of the given line and the point that we're looking for, right, to form the new linear equation. So first we're going to end up finding the slope, of course. So write an equation for the line that contains the point 5, 1 and is parallel to y equals 3/5 x minus 4. And you know that the 5, 1, that the x value is the 5 and the y value is the 1, right? So keeping that in mind, I can't get that x any better, sorry. The 5 is x and 1 is y. So now, first step 1, right here. First, identify the slope of the line. Well, the equation is y equals 3/5 x minus 4. And we know that the slope is the coefficient of the x variable when you're in slope-intercept form. And we're here, slope-intercept. So in this case, 3/5 is the slope. So now we know the slope. It's step 2. Write the equation of the line through the point 5, 1 using the point slope form of the line. Not slope-intercept. Now we're going to switch over to point slope. Okay? Not standard form. Point slope. Here it is. Point slope form of the line is y minus y1 equals m, the slope, times the quantity x minus x1. And the y1 and x1 are the numbers that you're going to stick in based on the point you're dealing with, right? Because the x and y by itself are the variables that are the dependent and independent variable that we're dealing and looking for. So the first thing we're going to do is substitute the terms. And what's the terms? For in the y on the left side, it's y minus 1 because the 1 is here it is again, the 1 is the y value. So it's y minus y1 equals 3/5. That's the slope. We determined there's a slope, and here's where the slope goes. Slope is m, so put the 3/5 in, times x minus 5 is the x value. Over here we see the x value was 5. So we put the x value here. So now we're going to use the distributive property to clear up this right-hand side. So we have y minus 1 equals 3/5 x. We multiply these two together, right? And then it's minus, got a minus 5 here, 3/5, here's the slope, times the 5, using the distributive property. And when we simplify this, we're going to have y minus 1 is equal to 3/5 x, right here, minus the 5's cancel, and you get 3, minus 3. Okay, these 5's here cancel. Okay, so now we have y minus 1 is equal to 3/5 x minus 3. Now the next thing to do is add 1. We have to get the y by itself. So let's add 1 to both sides. And you're going to get y is equal to 3/5 x. It was minus 3. We're going to add 1 to it. Now it's minus 2 because we added 1 to both sides. There you have it. Y is equal to 3/5 x minus 2. The slopes are the same, and the y-intercepts are different. One has a -4, and this line has a -2, so they are two parallel lines. Okay? Okay, example 2, check your understanding. So let me read it to you. It says, write an equation for the line that contains the point 2, minus 6 and is parallel to y equals 3x plus 9. So I'll wait while you pause and try this. And when you come back, we'll work them together, okay? Work it together. I'll wait for a few seconds here. Okay, Glad to see you made it back. Let's go ahead and do this. So write an equation for the line that contains the point 2 comma negative 6 and is parallel to y equals 3x plus 9. So first thing we're going to do is find the slope. Step 1, find the slope of the equation that's already in y-intercept form. And the slope is, I'm going to just write it again, y is equal to 3x plus 9. The 3 right here. You can change the colors. Let's do blue. How's that? The 3 right there is the slope. So slope equals 3. Next, we're going to use the point slope form of the line to write the new equation of the line that is parallel to this y equals 3x plus 9. It's parallel to it, but at the point 2 comma negative 6 is one of the points along that new line. Okay, so now what is the equation? It's y minus y1 is equal to the slope times x minus x1. Pretty straightforward. And now we're going to substitute. What do? We're going to substitute the y and the x value, the y1 and x1. y1 is negative 6, so we have y minus negative 6. Always keep them written. Don't combine them too soon, or sometimes it'll confuse you. M, okay, and I know what the M is. The M is 3, so I can put 3 times x minus. This time it's a positive number, so just plain minus 2. Now I'm going to solve to put this into the slope intercept form. Get the y alone on the left rather. So in order to do that, we're going to, well, this negative and negative 6 is a positive 6, right? So we're going to subtract 6 from both sides to solve this. So we're going to say y is equal to 3. Oh, well, we should, well, it doesn't matter. I can still do it at this point. So it's equal to 3 times um, x minus 2, and it was 6 we're dealing with, negative 6. So I'll leave the negative 6 for a second. I'm going to solve the distributive property. So I'm going to say y is equal to 3x. 3 times negative 2 is negative 6. Okay, and negative 6. Oops, got carried away there, Bob. Minus 6. So negative 6 minus 6 is negative 12. So the solution here then is y is equal to 3x minus 12. So the slope we come up with is 3, and we said that the new slope has to be 3, and the negative 12 is different than plus 9, so we've solved that. Well, and it's a different spot on the line, right? It's not the same as 9. Negative 12 and positive 9 are not the same. So these lines, yes, are parallel, right? Okay. Okay, now in objective 2, we're going to be looking for perpendicular lines. Okay, the lines at the right are perpendicular. We see them. There's a red line and the blue line, right? They're perpendicular. Perpendicular lines are lines that intersect to form right angles. So as you can see that these are, if I look at it, you can see that they're pretty much a right angle right there, right? The equation of the red line is y equals negative 1/4 x minus 1. The equation of the blue line is y equals 4x plus 2. Okay, so we can kind of tell right off the bat here as we're looking at them that we see that the y-intercept, we're in slope-intercept form, right? Both of these are already in slope-intercept form. And therefore we know that the slope of the red line is negative 1/4. And you have to know that negative slopes go down from left to right, and positive slopes go up from left to right. Okay, so this negative 1/4 is going down, and the one that's a positive 4 is going up. Okay, And the slope is, well, whatever the slope is. It's just, are they pointing up or pointing down? So just keep that in mind. You'll see that many times as you move along in your mathematics. So, and you're going to have to solve this quite often. So now we know what the slope of the two lines are. Okay, they're telling us that these lines are perpendicular. And the other thing you can know that here, this one says that the red line goes through -1 as the y-intercept. And here it is right here, -1. See, kind of convenient. And then the blue line, it says it's going through 2. Well, it's kind of 2. The line wasn't drawn very well. It's kind of looking like 2, but it's 2 it goes through. Okay, so slopes of perpendicular lines. Two lines are perpendicular. Two lines, I'm going to change this to a darker blue right here. Two lines are perpendicular if the product of their slopes is -1. A vertical and a horizontal line are not, excuse me, are also perpendicular. I'm getting ahead of my reading here. The vertical and horizontal lines are also perpendicular. And you can see that right here in the drawing of the graph itself. Here's the x-axis and the y-axis, and they're perpendicular to each other. So that's the information to know here, right? And it says here that the slopes, when you multiply them, gives you a -1, and we'll see that right away here. A horizontal line and vertical line are perpendicular. Example, the slope y equals -1/4 minus 1 and is 1 minus -1/4. That's the slope. The slope of y equals 4x plus 2 is 4. We know that. Here's the 4x, that slope, and here's the -1/4 x. Since -1/4 times 4, right here, is equal to -1, because the 4's cancel and you end up with a -1, the graph of the two equations are perpendicular. It's that simple to know if they're perpendicular. You just multiply their slopes together, and if it comes up -1, they're perpendicular. Okay? Okay, continue on with objective 2, perpendicular lines. So the product of two numbers is -1 if one number is the negative reciprocal of the other. So that's the idea, is the negative reciprocal is you flip the number over. So if it's a fourth, it becomes 1. If it's 4, if it's a fourth, it becomes 4 because you flipped it over. Let me write it. Again, we did this. 1/4, the reciprocal of that is 4 over 1, right? You flip the number on its head, flip it over. The negative reciprocal is you just take the number, flip it, and then add a negative sign. Okay? So let's look at what it says here. So it says, here is how to find the negative reciprocal of a number. Start with the fraction, -3/5. And then we're going to find its reciprocal, which is -5/3, right? We flipped it. The 5 went to the top and the 3 went to the bottom. 5 on top, 3 on the bottom. And then write the negative reciprocal. Since it was a -5/3, it's now the negative of a negative is a positive 5/3. That's simple. Since -3/5 times 5/3 is equal to -1, 5/3 is the negative reciprocal of -3/5. Kind of what we've been saying here now. Okay. Start with the integer. I used 4. They're using it here too. I guess I should have used another number. Start with an integer, 4. Find its reciprocal. Flip it over. 4, don't forget, 4 is 4 over 1. There's always an understood 1 in the denominator of, of a number like 4 or whatever. Okay? And then we flip it over and then find its negative. So you just multiply whatever you have by -1. It could come up positive or go negative. Since 4 times 1/4 is equal to -1, since 4 times -1/4 is equal to -1, the answer, -1/4, is a negative reciprocal of 4. Okay? Good. Okay, example 3, writing equations of perpendicular lines. So it's going to be exactly the same as we did writing the parallel lines with one change, one simple change, and you'll see it immediately here. So it says find the equation of the line that contains the point 0, -2 and is perpendicular to y equals 5x plus 3. So the first thing we're going to do is find the slope of the given line, remember? Okay, identify the slope of the given line. Well, the given line is the y is equal to 5x plus 3. So the slope is right here, the 5, right? There's the 5. So 5 is the slope. I'm going to write it right here. 5 is the given slope. Next, find the negative reciprocal of the slope. Well, the negative reciprocal is we started with 5. Here it is, 5. And we just took and put the 5 on its head, 1/5, and made it negative right here. 5 is negative 1/5. See that? You just flip it over and change the sign. You have to change the sign according to what the sign is. So you don't forget, if it's negative, a -3, for instance, it would be a positive 3, right? And then if you're going to, so if you flipped it, if it was a third to begin with, if it was a third, if it was a negative a third, you'd have to get it correct first before you could do it. Or if it was positive, you have to solve the mathematics of the sign conversion before you worry about flipping it. Okay? So then use the slope-intercept form to write the equation. So you can, now that you know the slope and you know why do you know the intercept here? Well, okay, we know it because here, I'll show you. Y is equal to mx plus b. So we're going to substitute the negative 1/5 for the slope. But how do we substitute the negative 2 for the y-intercept without drawing it out, right? Well, how do we know? It's because we go back up here to the givens, and they're telling you that x is 0. Right there, x is 0, and y is -2. So that literally means that when your line hits the 0x, it's going to be at -2, right? So -2 down here, and it's going down this way, so it's going to be like, all right? Well, they know because they said that it was, this point here is 0, comma, -2. That's this point right here. The x is already 0, so it's kind of easy to solve this problem. So we have y is equal to -1/5 x plus -2. Okay, here's where we have to deal with that, plus and minus. So simplifying, you get y is equal to -1/5 x minus 2. And that is the equation of our line. Okay. Okay, example 3, check your understanding. Write the equation of a line that contains point 1, 8 and is perpendicular to y is equal to 3/4 x plus 1. So why don't you go ahead and pause this and give it a try. And when you come back, we'll work it together and see how it turns out, okay? Okay, write the equation of the line that contains 1, 8. So the line has to go through that point where x is 1 and y is 8 and is perpendicular to y equals 3/4 x plus 1. So what's the first thing we do is we start with the given line because we want it from the given line, and it's already in slope-intercept form, right? So here it is, slope-intercept form. We've been given the slope right here, 3/4. Well, so we're starting with that line. Now what we want to do is identify the slope here, and we want to convert it to its reciprocal, its negative reciprocal. So in order to do that, we're going to take 3/4 and we're going to write it as 4/3, the inverse of it. And it's a positive number, so we're going to make it negative. So keep that in mind. And then we're going to plunk it into a line. What type of line? We're going to put it into the point slope form of the line. Because we know the slope and they've given us the point. So we're going to use point slope. It's pretty understandable. So what is the point slope form? The point slope form is y minus y1 is equal to x. No, excuse me, not x. Slope is equal to, go back to slope, is equal to m times x minus x1. That's the point slope form of the line. We know the slope, and here it is. And we know that the y point that they want us to use for the y1 is the 8. So it's y minus 8. It's always minus, unless the number is negative, then you convert it. So y minus 8 is equal to minus 4/3, because we converted it here to the negative reciprocal, minus 4/3 times x minus 1. And the minus 1 is, we're subtracting 1, which is the x1 value. Now you now have the new form of the line. So now we're just going to solve and put it in slope intercept, because now we want to be able to draw it and see this where it would intercept on the graph and whatever, right? So now we're going to do that. We have the equation here. Now we're going to solve it. So we're going to take and we're going to first multiply the distributive. On the right, we're going to get rid of the distributive property. So we're going to say negative 4/3 times x is negative 4/3 x, and negative 4/3 times negative 1 is positive 4/3. So now we have to get the y by itself. Getting the y by itself means adding 8 to both sides. And we can add 8 to the left side, and we're going to get 8 minus 8 is y, right here, y. And we're going to get negative 4/3 x, that stays. And we're going to get 4/3 plus 24/3. 8 is 24/3, positive. So plus 24 is 28. So now it's y is equal to negative 4/3 x plus 28/3. And if you simplify that to get rid of this improper fraction, we'll have the perpendicular line to the line, the starting line up here in the top. The perpendicular line is y is equal to negative 4/3 x plus 9 1/3. 3 times 9 is 27, plus 1 is 28, and that's what we want, is 28/3. Okay, good job. Okay, example 4. It's a real-world problem. These are always fun. A bike path for a new city park will connect the park entrance to Park Road. The path will be perpendicular to Park Road. Write an equation for the line representing the bike path. So Park Road runs through, you'll see it on the graph there, and the new bike path runs from the entrance, which is shown on the where it says park entrance, right here, park entrance, right there. And it's going to run perpendicular straight to Park Road. That's the new bike path. So what do they want us to do? They want us to draw draw a line, I guess, or what does it say? Write the equation for the line representing the new path for the bike path, okay? So now that we have that, we see here's Park Road. Let me get a different color here. So here's Park Road right here. And we want a line perpendicular to it, like that, right? And we want a line that's perpendicular to Park Road, but it's got to come right here from the park entrance. And I'm going to try and draw a perpendicular. It's not going to be, but that's what they want us to draw. A bike path from here, from the park entrance, right to Park Road. And now the graph on the right kind of shows exactly the same thing, but so that we know the park entrance point, and we have 2 points. They're showing us 2 points on Park Road. The one that's 4, 5, which is the points on our coordinate graph here, right? Our Cartesian graph. And 2, 1 is another point. Here's 2, 1 right here, and here's 4, 5 right there. Those are the 2 points that we're going to use to solve this problem. So the first thing we have to do is find the slope. Well, where do we get the slope from? Well, since they don't give us the slope, they're just giving us 2 points, we're going to need to use the slope formula. And what is the slope formula? It's written down here, but I'll write it again. It says that the slope, I'm not going to use dark there, I'm going to use orange. It says the slope is equal to y2 minus y1 over x2 minus x1. And you solve that and you'll come up with the slope. And as we move forward, I'm going to use this upper point right here. I'm going to go back to the dark color. I'm going to use this point right there as my end point. And the starting point is down here. So 2, 1 is the starting point in my formula, which are the 1 values, y1, x1. And the ending values are 4, comma 5. That's our y, our x2, comma y2. Those are those values up here on the top, okay? So when I write this, and keep in mind, I could do either point. I could say I started at the top and went to the bottom. It does not matter as long as you keep it straight in your formula and you use the correct ones. I'm going to use the starting point as the bottom and going up to the right. That's the point for the second point. So the second point are the twos, y2 and x2. So what do I have? My slope. It's over here, y2. I'm way over here. Well, got to go back to gold. I'm way over here now. So y2 minus y1 over x2 minus x1 is 5, which is the y2 value up here. 5 minus y1, which is the 1 value down here, and over 4, which is the x value for the ending point, and 2 right here, the 2 is the starting point, x point. And when I solve that, you're going to get 4 divided by 2, which equals 2. So points 2 and 1, 2 comma 1, and 4 comma 5 are on the road. They show you they're on the road, and we're going to draw a line now perpendicular to that. Well, what is that? So the negative reciprocal of 2 is negative 1/2. We flipped the 2, which is 2 divided by 1. We flipped it over and made it 1/2 and took the negative of it. And the slope of the bike path, so is negative 1/2. And the y-intercept is what? It's 4. Because as you see right here, here's the 0 point right there. So you don't have to go any farther than that. You know that the y-intercept is right there because we look at 4, we see where the line, that's where we started the park entrance, right at 0, comma 2. Okay? And therefore, the equation for the bike path is y equals negative 1/2 x plus 4. Okay, example 4, check your understanding. This will be your turn, your chance to see if you've kind of put all this together. So let's see what happens here. A second bike path is planned. It will run parallel to Park Road and will also contain the park entrance. Write an equation for the line representing the bike path, the new bike path that's parallel to Park Road. So why don't you go ahead and pause the video, and when you come back, we'll work it together, okay? I'll give you a few seconds to pause it. Okay, I assume that you've done the pause, and let's give it a try here. So what don't we know? In order to find whether it's parallel or perpendicular or whatever, we always have to have the slope. And they don't give us a slope. It's the same as this is the same park from the previous slide. We can remember that the slope was 2, or we can just calculate it again. So we can go in here and we can say, well, what was the slope? So the slope is equal to y2 minus y1, so 5 minus 1 over 4 minus 2, right? 5 is right here, and the minus 1 is right down here. The 1 and the 4 is up here. This is up on the ending point. It's the same one I used before, and the 2 is down here in x. So when you do that, you end up with 4 over 2, and you end up with 2. So what's going on here now? We want a line parallel. So do we need to get the inverse of this? No, you only need the inverse when you're doing the perpendicular lines. So we now know the slope, and we want us to write the equation, write an equation for the line representing the bike path. Well, the way to write that is to say y equals mx plus b. Now let's fill it in. So y is equal to, what's m? M is the slope. What's the slope? It's 2. 2x plus, what's b? Well, they told us that it also contains the park entrance, and b is the y-intercept. Well, again, here's x0 because the park entrance is right on x equals 0, And the value was, what was it? It was 0, comma 4. Well, that's right there is your y-intercept. So the b is y-intercept, so it is plus 4. So y is equal to 2x plus 4. Good job on them. These are interesting problems and they're getting a little tougher.